The next topic we're going to talk about are scientific models. So a model is a group of statements to describe something, and it's often used to define that thing. Examples of models are the atomic model, the energy interaction model, the mechanical wave model, a mirror model, etc., etc. So it's not necessarily good to think about it as a physical thing. You know, if you had the Earth, like a big ball that was the Earth, and then you had like a chunk cut out so you could see all the stuff inside. The model that we would talk about in kind of this definition of a model would not be the model, the physical thing itself, but it would be the ideas or the statements that make that up. So for example, there is a core at the center of the Earth. Then there is a rings extending outwards until you eventually get to the crust. It's like those statements or those ideas would be the model, not necessarily the physical thing. The physical thing would just be a physical embodiment of those statements or ideas. Why do we use models? In physics and in science, there's a bunch of reasons, but basically simple definitions are usually insufficient to describe complex phenomena. If we do waves this year, you'll see how a wave is really hard to define using just words. But if we come up with a couple of statements, it's a lot easier to define it. We can say a wave is something that does these four things. Some phenomena can't be directly studied. For example, the atom, we can't look inside an atom and see what it's made up of. So we have to do experiments and then, based on the evidence, make a model that says, here's what we think is making up an atom. It also helps us promote an understanding of a concept. So if we have to have all these statements, it means that we have to actually kind of describe what's going on rather than just say, oh, it's blank. Models can also easily be adapted to new evidence. If you see some new observation, you don't necessarily have to redefine everything. You just look for which of our statements is no longer true, and how can we change it to be a statement that is true. And then lastly, this one's kind of the interesting one that is particularly relevant for our class, in that some models will simplify complex phenomena so that you can work with them more easily. So I mentioned this before, but technically everything that we're going to learn in this class is not the full, complete, most accurate, most up-to-date understanding of how we think the world works. But it's a simplified model that is accurate for stuff that happens day to day on the Earth. And since that's our normal experience, that's great. The math to describe more fully what's happening is a lot more complex and a lot more involved, and the results you get end up being basically the same. So using a simpler model still gives us accurate, correct answers, but it's a lot easier to use and to do that work. So that's the reason that we really care about it for this class, is it helps us to access and understand and describe what's going on.